Well, hello. Good morning, everyone. And after such a big picture talk, I have to sort of bring you down to something nitty-gritty, such as databases. So, which of you here loves databases? Okay, what about hates databases? Anybody who doesn't give a shit about databases? Okay, wonderful. All of you are my people. Oh, I just have to say that. No, which who doesn't give a shit about databases, you're not my people. But anyway, let's me start by asking you maybe, how do you guys run your databases in the team, right? Which of you are responsible for databases in your organization? Anyone? Okay, that's cool. What about when you have like a separate team in an organization which is responsible for that? Yeah, that's a way. And which of you are trusting some, third-party vendor to fully manage databases, manage services, this kind of stuff? Yeah. So we can see there's all the different things can happen how you operate databases. Now, I think in most of those cases, you can see this sort of a conflict where wherever a single developer is or the separate team, where a developer just wants to expect the database to do the right thing. It's like, oh, why is it always slow, goes down, it's a messy, nasty thing. And then if you think around database operations, and actually, well, you can think about that, a database itself, right? Say like, okay, my dear developers, why can't you just the right thing, right? Have you heard about such thing called indexes? Anyone? Indexes, right? So that is what we often see those days. Now, also a question to you all, and that was a requirement for all the speakers have to talk about AI or agents. So I added this slide to ask you, did anyone here go on kind of fully agentic when it comes to databases? Like, I don't touch my database with my dirty hands, and I have my smart AI overlords manage databases for me. Anyone? Yeah. Well, I actually did a poll on this as well, right? And you can see what that is not really what's happening with databases, indeed, right? We still have that people, right? And like a 5% people maybe just doing that for fun or clicking the right button, right? Or don't understand English. There's all kind of people. Even in my LinkedIn. Well, anyway, with all of that, if there is sort of like one takeaway from my whole presentation, it would start with this kind of word which actually guys say AWS like to use a lot, called like a shared responsibility, right? And of course, they use that in a different way, kind of, like to avoid all that kind of, responsibility, kind of legal risk and all that other shit. But in reality is you have to have that shared responsibility for ultimate success of your databases. It cannot be just developer problem or operations people problem. It has to be everyone problems. And with that, let's talk about some top recommendations for developers. First, I think it's very important to understand the choices. There are a lot of database choices on the market. There are sort of open source software. There is a software which is marketed like open source, but which isn't. Hello, MongoDB. There is also, proprietary software. There is software which can be, run in the cloud, many clouds which you chose. Basically, a lot of choices, and all of that really comes with implications. And I think it's very important to think about those implications specifically about the database compared to many of other applications, often stateless, right? Because what we often say about a database and about the data is what data has gravity. And lots of data has a lot of gravity, right? That means if you have stored, few petabytes of data in something like, Snowflake and build all your framework around that, that would be very hard to move that somewhere else, right? And that is like one of the case, for example, the venture industry, they like the database companies and companies which, provide those proprietary solutions as regards to your data, because they can be very, very sticky because it is hard to move, right? And that means what your choices matter even more. And if, your control, your vendor independence is important from you, you want to start with data and your database. The other thing which I would mention for developers, we often, basically helping people with database kind of on the receiving end, right? And we often see what developers like to blame the database because they often do not understand the database, right? And I think the first thing, I think it's important to be able to answer the questions, is that even a database, right? There are a number of tools you can use in observability space to use that. I will plug the open source tool Karoot, which I'm kind of helping to. It has some very good solutions in this regard. The next thing I would encourage all developers to learn the database basics. And of course, increasingly right now, right, you can ask AI to create your schema, write your queries, right, and so on and so forth. But as some folks say, you want to be able to trust by verify. If you don't understand, how queries work, how databases work, what are indexes, schema design basics, you are likely to get sooner or later into trouble, because at this point, AI doesn't have 100% body average, right? And and that means sooner or later that will get you into trouble. So here is example, for example, of like relational schema design, right? Hey, you want to understand what that works, okay, at least on the basics level. Query execution. That is the query execution diagram for one of like an early MySQL versions. Okay, at least you want to understand, hey guys, there is this optimizer which will pick out something called a plan, right? And that will use such things as an indexes, right, to access your data fast, right? Or maybe some other structures. You want to understand those things. You also want to understand the tools called explain, right? And I think what also is wonderful those days is often even if you don't understand explain, you can ask AI to explain to you. Right? And it can be very helpful, right? Hey, oh, this is bad. Right? Like, oh, this is no. I've seen AI is like any LLMs out there is very good at that. Actually, often you can, paste your query, explain statements, and maybe, schema, and that can be your sort of like a poor man's AI tool, right, to optimize your query, but also very, cheap, because a lot of advanced observability tools are freaking very, very expensive. Hello, Datadog. Well, you can also visualize some other tools, right, to visualize in the queries, like this is a nice PostgreSQL plan visualization tool which you can go about. With AI query optimization, I kind of mentioned that the first is a very basic approach, right? You can just feed that to your LLM. We often see now what people deploy in MCP servers to their databases, and that can do a lot of that kind of heavy lifting. Or I will skip, I can run explain, I can fetch schema details. Just be careful, right, in terms of what permissions you give to your MCP server and what kind of, who can access to that MCP server, because all things with AI are very early stage, and everything early stage tends to be horrific with security. right? So that is sort of a danger zone. Cloud Code and other similar tools, right, can also do a lot of heavy lifting for you now to help you to optimize your query. And there are also some of a specialized tool which can do some deeper analysis. So some interesting things here where can be also pulling the different data points from maybe different systems, like the tool Karoot I already mentioned, that can pull the data from, we know what in a recent deployment the schema changes and the index was dropped, and that correlates if a query got slow, right? So you probably screwed up something in your latest deployment, right? So it can do those analysis because it can look not just at your query, at what else happened in your system. Another thing I think which is very good to understand when you're working with database is what exactly queries are creating a load on your system. Because that may not be slowest queries, that may not be most frequent queries, right? That's all kind of depends. This is a screenshot from a Percona's tool called Percona Monitoring and Management. So there are a bunch of other tools which can also provide similar functionality. The next thing what you want to understand in terms of basics is how queries are executed, because that depends on how you can design system to scale. If you think about MySQL, for example, it optimizes or executes a single query in a single thread. Postgres can use multiple CPUs. It has parallel query executions, right? But it's limited to a single node, even if you have what you think is PostgreSQL cluster, right? That's probably for high availability, maybe load balancing, but it's not going to, out of a box, optimize a single query. Then there are some other solutions like ClickHouse, right, which runs the queries in parallel by default. You want to really understand that. And again, that may look as a basics, but I've seen a lot of developers can treat a database as a black box, not really understand how that works inside. We spoke about indexes. Indexes are must for good performance, but they're also very expensive. I've seen people going with no indexes, and that's horrific, and I've seen people indexing every freaking column in their database, which is also very bad idea. Right? So saying, oh, we talk about indexes, let me add some. Well, you want to be careful with indexes and adding only the indexes which you need. The next thing I would say is important is to understand capacity planning. No database have unlimited scale, right? You want to make sure you understand that. And I think what is important here is what scalability is also can be very application dependent, right? And in this case, you should know what all the vendors out there, they like to report their best case scenario. Oh, we can handle quite, like a gazillion transactions with a 0 milliseconds latency. Well, maybe in some, lab tests, we were able to achieve that not necessarily can be your case, right? Check if your application, in applications you may have some sort of like a hotspot, for example, when you have like a single point of data which is being updated by many threads, and that just would not scale on a lot of systems, right? But that's probably not what vendors which wants to show the best results are going to be done. When it comes to scalability, typically, we use one of those two approaches, or often combination of them, right? Which is talk about vertical scaling and horizontal scaling. Again, not all of them are equally used with different database systems, and sometimes you need some other solutions, right? Like, for example, when you look at MySQL or Postgres, which do not have built-in horizontal sharding solutions, we are using something for sharding. Right? Maybe it's Citus, maybe it's Vitess, maybe it's some other solutions are coming up to the market, but we can use something. The next thing to point out is there are two words that we often hear when it comes to databases, like a scalable or an efficient or performant, right? And they kind of sound almost the same, but they're really not. And they are often actually the opposite. Because if you think about some like a very, very efficient high-performance system, right? Hey, you remember while Redis or Memcache became very, very fast and popular. Hey, it's in memory, it's a single thread, we don't have to deal with any of that stupid locks and so on, very, very, very fast. But that does not scale, right? You cannot, if you want to have like a parallel execution, you have to deal with some solutions, right? You have to go beyond memory. It becomes more complicated, and so scalable often comes at the performance overhead, and that's good to know. And what also that means is what you often want to choose the systems which are appropriate for your scale. Sometimes, if your application is not going to grow very huge in foreseeable future, right? You want to choose less scalable systems, but which are simpler, more performance, more cost-effective, and so on and so forth. When it comes to scalability, there is also good to understand what the throughput is not the same as latency. So if I'll tell you we have a system which can handle 100,000 queries a second, right? What can you tell me in terms of how responsive that system is to a user? Well, yes, nothing. And that's good what some of you understand that. But for many, it's like, 100,000 requests a second, that is very, very fast. But I can say, well, you know what? What about if each of those requests in 1 second, then I just have a concurrency of 10,000 requests at the same time, which system can accept, right? It will process 100,000 requests a second, but it would not be fast. And that also brings us to understanding the speed of life limitations, right? Often that comes when people talk about the high availability, building robust systems. We want to build a system with which is a geo-distributed synchronous replication and also a very, very fast response time. Well, it doesn't work this way. You have to pick something, right? Sometimes that means what you have to, maybe keep a tight, collocated solution for high availability, right? And then just have asynchronous replication going into DR, which is located somewhere else or some other solutions. The other thing when it comes to those kind of global wide area networks is what they tend to be different compared to your local network. There is a lot of shit which can happen on the internet, right? And I just don't mean like discussions on Reddit, right? I mean like, cables being cut, some fires, natural disasters, right? And wherever, right? So then in your local network, typically the latency between two nodes is kind of very fast, very predictable. It's always the same way. How things go between two nodes on a different continent, it's going to vary very specifically. And you need to plan for that. And often it's also something what can expose itself over weeks and months, right? You can't just say, things are pretty reliable now between here and London. Well, yes, now. That doesn't mean it's going to last. Another thing what when it comes to latency, I would encourage to understand what the connections to a database are expensive. Maintain them if you can. And also do not use more queries than you absolutely have to. I've seen some people would create applications which have thousands and thousands of queries, one after another per user action. It may work very well on your laptop, right? But that doesn't work very well when you separate your application and database at all. ORMs, wonderful tool, I think, that helped a lot of developers to write applications with databases, but they also can create trouble. And what I encourage people to understand, well, if a database can't handle certain queries, well, it can't handle certain queries, right? And the fact what your very nice ORM generated them for you, right? Well, it's not help, right? So you should be using ORMs, but understand what sometimes ORMs does not create good queries, and you need to, somehow to be ready to adjust them. Another little thing is what developers often miss with databases is how transactions behave, right? What you want to be very careful about is starting transaction and then going to user and asking them for input, Not a good idea, right? Because that limits scalability, gets a whole bunch of different options. When you open transaction, do operations you absolutely have to do, and then close transactions. Commit and roll back, do not keep it open. The next thing is, when it comes to the database, is concurrency, right? If you take a database, right, its throughput, how many transactions it can handle, will of course increase as you increase transactions, as you launch parallel, but only to a certain point, right? What you will see in this case, right, even if you have like a lot of CPU resources available, typically as the concurrency goes down, right, you have it the best model by this what's called universal scalability law, which tells us there is this optimal concurrency which database can operate. And it is the best if you keep your database somewhere in that space. How do you do that? Well, you do that by embracing some sort of queuing on application, maybe on some connection pooler database, which can say, hey, you can open as many connections to me as you want. I'll kind of queue them and only maintain, I don't know, let's say, n number of connections and concurrent executed queries for the database, which keeps it in that sweet spot. And there are, a bunch of other the benefits of connection pooling. Now, there is another thing that you need to remember about the databases and the gravity, right? And this is this, right? I mean, whatever your database is, but shitty database, shitty application can bring down any database, whether it's like, like a fully managed distribution, and so on and so forth. Okay, I just have 5 minutes, so I continue going quickly. Next, scale matters. With database, a lot of things don't scale linearly, right? So when you're testing things, you don't want to be testing them on, 1,000-row database on your laptop. You want to make sure you get the realistic scale systems if you care for your testing to be appropriate. There is also a lot of difference in performance between memory and disk. And that is still the same, even though we got like very fast SSDs, which can now shovel gigabytes a second. There is still multiple orders of magnitude difference between accessing the data on SSD and kind of hitting sort of like a cache data in your CPU cache, right? So you want to understand where you're going to behave, right? And if your application is again and test it in a realistic scenario. Don't test if all the data in memory, if actually it's going to be on disk. Or if or maybe you plan your system data set is small enough, you just need to buy enough memory. Newer is not always faster. Something also, right? As you upgrade, there may be new architecture choices, there may be new bugs, there may be something else. It was interesting, just MySQL, for example, released in MySQL 9.7 new hypergraph optimizer, which is faster in 75% of the queries, but there are 25% of the queries which are slower, right? Well, and you may be running some of those queries, so if you check how that impacts you. I would also encourage to work with upgrades. What you often see is people say, hey, you know what, we don't want to upgrade the database, we want our developers kind of focused on providing features which are valuable for business, and then you can get to a point where a database is not supported anymore, and then it has some CVEs, right, which your boss says, hey, we cannot run that stuff anymore, well, and it takes a lot of work to upgrade. So I would encourage to plan, in your case, sometime to do the regular updates with a database as a part of your life cycle, not so you don't have to do it as an urgent thing. You also want to not only think about your normal database, normal operations, but also various operation stuff. How does backup impact your application, or how you're going to change your table structure? For example, adding an index or column, right, or something else restructured on a 10 terabyte table, that takes a lot of time, and that may impact a lot of things, how you design your application, how you design your workflows, and so on and so forth. Distributed systems, I think I mentioned that briefly, right? You want to understand implications which come with them. The more complicated systems may be more reliable, maybe more scalable, but they also have a ton more failure scenarios for you to consider if it's a must for you. When you think about the automation, we all have to automate stuff, right? Like, the date when your keyboard, typing DBA is over. But also, it's important what the mistakes can easily destroy database at scale. And even if you have a perfect backups, bringing them back can be quite a time, right? So you want to test your automation. And especially right now, when you're bringing AI for automation, you're adding another complexity level. And also what is challenging with AI, it is less predictable compared to your well-tested bash script. Right? We don't always know what exactly is going to happen in those models, right? So I would encourage to make sure, right, what you keep a human in a loop for critical, database decisions. And their last one is security thing, right? You guys have to understand what probably understand what the database is where the most sensitive data lives, right? So that is absolutely such a wonderful thing for any hackers out there. Database, so it's backups. It's data which is well laid out. You clear what is what, right? So be very careful of that. And again, I would use that as a word of a shared responsibility. There are certain things that operations have to do with that stuff, but there's certain things developers have to do as well, right? If your application is going to be kind of allowing people to do SQL injections, right, and extract the data in other various ways, there is a very little ops can do, because in the end, your applications need to have an access to a database which is required for its functionality. And with that, it's all I have to say. Hopefully that was helpful.